Merge sort is a highly efficient sorting algorithm known for its divide and conquer approach. In this video, we'll break down the merge sort algorithm step by step, making it easy for beginners to understand. Assume we have an unsorted data like this. Merge sort operates by dividing the input data into small groups of the data until each group consists of only one element. So, as you can see that it is dividing each group into two parts. This is called divide approach. These single element groups are already sorted, as they contain only one element, so no need to proceed further. Once the data is divided into single element, code will now merge these smaller groups in a sorted manner, gradually building up a fully sorted data. During the merge process, two groups are compared element by element. For this we have three pointers I, J, and K. The smaller element from each group is selected and placed one by one into the above list from which it came. This process continues recursively, with larger and larger groups being merged until the entire list is sorted. The time complexity of merge sort is order of n times log of n, in all cases, where n is the number of elements in the input list. The n times log of n complexity arises from the fact that during each merge step, the algorithm divides the list into halves, which takes order of log of n time. Then, the merging step itself takes order of n time. Since the merge step is performed for each level of the recursion, the overall time complexity becomes n times log of n. The space complexity of merge sort is order of n because it requires additional space for the temporary arrays used during the merging process. The code is provided in the description below.